This will be fine. Yes, will be. Okay, I know you guys need to work hard for like 2 weeks in chemistry, and then we just do lots of experiments after that, okay? But you have to know your naming really well to be able to even do experiments, because else you won't know what you're experimenting with. That's a problem. Okay, so there's this format called IUPAC, okay, IUPAC, and it is like the system for how to name stuff. So, do you know what it might stand for? IUPAC? What's the I?
International.
International. Union of pure and applied sciences. I mean chemistry. Thank you. Oh dear. I'm thinking of like faculties, pure and applied sciences. Okay, it was founded in 1919 and has developed a method to name chemicals based on their composition. So that all over the world we can name all of the chemical compounds the same, and it won't be like, oh, well that's dihydrogen monoxide. And they're like, no, wait, that's hydrogen peroxide. And it's like, well, what is it? Is it water or is it something deadly? You know, gotta know. Okay, so how do you do it? Oops. Well, the first name, use full name of cation. That's usually the metal. We'll get into when it's not a metal later. Then next, put the name of the anion last and change ending to I. This is usually non-metal. Okay, so got your periodic tables out in front of you?
Yeah.
Okay, so what is Na?
Sodium.
So you just write the cation as normal. Sodium, and what's?
Chloride.
And so then it's chloride. And that one, that's nice and familiar. Okay, next. What's Li?
Lithium.
Lithium. Then what's next? Bromide. Okay, what's Ca? Calcium. What's next?
Oxide.
Oxide. Okay. Next one, what's Sr?
Strontium.
Strontium. Tium. And next?
Dichloride.
Well, no, just look at what it is. Just look at the element and add "ide."
Chloride.
Just chloride, yeah. I'll show you about the numbers in a minute, but for now, you just look at the element, add "ide" at the end. Next?
Barium.
Barium.
Barium. Fluoride.
Fluoride, yeah. Next, the K means
Potassium.
potassium. the next is sulfide. Now, you should be observing something in this list of examples, and you should be thinking of a question that you would like to ask me.
What are the numbers for?
That's a good one. We'll do that next. Yeah. What's something in this list of examples we haven't discussed besides the numbers? The S. What does the S mean? Solid. Why are they all solid? They want to be. What types of compounds are these? Ionic compounds. Yesterday in our notes, we said all ionic compounds are solid at room temperature. Okay, so let's make a note of that to ourselves, that S means solid. And remember, all ionic compounds are solid at room temperature. That doesn't mean that they can't change the state if there's enough added energy or energy taken away, but they are solid at room temperature. Okay, now is the fun part. I teach you a trick. Okay, tricks are fun, right? Yeah?
Kind of.
Yeah? Okay, so here's the trick. The chemical, pardon?
I'm not there. Just need the words.
You want me to go back?
No, okay, it's okay.
All right, so the chemical formula is the simplest whole number ratio of each type of ion in the compound. And it represents the smallest repeating unit or formula unit within an ionic compound. There are no prefixes in naming ionic compounds, and that's like mono, di, tri. That's not in ionic compounds, ever. Well, except for anhydrates. I'll get to that later. Okay? So how do you know about the numbers? Because you guys were wondering about the numbers. So if you don't get to use mono, di, tri, how do you know about the numbers? Okay? So I show you. Write the metal element symbol with its charge. And the non-metal element symbol with its charge. You then balance the ion charges. Then I said underneath there, I say trick, right? Yours says trick. And the trick is called criss-cross. I show you what that means in just a moment. But the trick is to criss-cross. Write the formula indicating how many atoms of each element are in it with a subscript. So that's like with the number down below. So the number is below. And then I have in your notes there, I say make sure, and the note for make sure is lowest ratio. So the lowest whole number ratio. I'll show you what I mean by that too. If there is only one atom of an element, no subscript needed. So like with sodium chloride, you don't write Na1 and Cl1. You just leave it. Assume it's one. Okay, so now we do lots of examples. Okay, so let's start with something simple like we've done before already. So let's say we start with sodium chloride. Okay, start with sodium chloride. You write the cation with its charge. What's sodium's charge when it's an ion? +1. Chlorine's charge when it's an ion is -1. Now, what you do next, step 2, balance the ion charges, crisscross. So you take this number, put it there, this number, put it there. So now it's NaCl with a 1 and a 1, but you don't have to write the ones. Okay, this will be more clear with another example too. So let's say that was example 1. Let's do example number 2. Let's say we have barium. What was from your workbook? What did you have? It was barium what?
Barium sulfur. Barium sulfur.
No, I don't want to do that. Okay, let's do barium chloride. Actually, let me see your workbook first. I want to do one of these. I'll do that. Okay. Okay, so barium chloride. So let's draw barium. So Ba, and what's its charge? You can look on your periodic table. It's always, you look at your periodic table. It's Ba2 plus. Cl is 1 minus. Now you crisscross. So this 2 goes there, and this 1 goes there. So you just crisscross the numbers. So now I have Ba1 and Cl2. What?
9.
Okay, I show you one more example that will look just like your workbook one. So open up your workbook to what we just did and go to the potassium and oxygen one. Potassium and oxygen one. So let's do potassium and oxygen like this. So let's say we have, so you can just put it to the side, have your workbook open, but we'll do this. So we have potassium, and what was it, oxygen? Okay. So it's potassium oxide. So we have our potassium is K plus, and oxide, oxygen, 2 minus. Cross, and I'm left with K2 and O. Look at your workbook. What was your final answer?
K2O.
K2O. That's why. So that's why this crisscross method always works, is because of what you guys just showed me in your electron dot diagrams. Isn't that crazy?
awesome.
I know, right? So you can do it the way we just did, or you just make a crisscross and you're done.
So the minus doesn't matter?
The minus doesn't cross. It's just the numbers that you think of crisscrossing. Okay, let's do one more that's a little bit more complex. Okay? Let's do, oh, this is number 4. Potassium, phosphide. So with potassium phosphide, we have our K plus. Phosphide is P what? 3 minus. So I cross and I get K3 P. Do you have room for one more? I show you one more because I know you're going to ask me about it soon. One more example. Calcium sulfide. So calcium is Ca2+, and sulfur is S2-. We still do a crisscross, so I end up with Ca2S2. Is that the lowest, the simplest whole number ratio? No. So what does it need to be instead? So this is wrong. So it needs to be just CAS. Because the simplest whole number ratio, you just divide each of these by 2. Okay? So now you can do the questions that are, you flip your page and you do the next question. Did you already do it?